Welcome to math classes. In this video, we'll see some more definite integration PYQs from JEE. All these problems are numericals, not multiple choice questions. Okay, so these are all really complicated, and everybody should solve these such problems actually more. Okay, this is a very good preparation for your definite integrals. Okay, let's get into this. Let the square bracket denote the GIF function, greatest integer function. If integration from 0 to e cube of GIF of 1 by e to the power of x minus 1 dx is equal to alpha minus log 2, then what is alpha cube? Okay, first thing is simplify this one. Okay, don't keep denominator and numerator and denominator here. So this is nothing but e to the power of 1 minus x. Now all you need to find is GIF of e to the power of 1 minus x, and between this range, what are the values possible here? Okay, that's what you need to find. We know that e cube is approximately 20.08. So we need to check e to the power of 1 minus x at integral values. Correct? How many integral values will come in this range? Okay. So first thing is, we know that e to the power of 1 minus x is always greater than 0, and its maximum value is e. How? You'll get when x equal to 0. Anything as x is increasing, the value will go down. Okay. So this will range from e to 0. Okay. 0 not inclusive. And the domain is from x is moves from e0 to e cube. Okay, so now in this domain, okay, 0 to e cube, how many integral values is possible? E is around 2 point something. So all you need to know is when it is 1, when it is 2, when it is more than 2. That's it. 3 ranges we need to find. Okay, so first thing is, let's find the 2 when it is 2 basically, because above that everything is 2. Okay, so e to the power of 1 minus x is equal to 2. If I equate it, then I get 1 minus x equal to log 2, or x is 1 minus log 2. So anything above x value, below, because it's reverse, right? At x equal to 0, it is maximum. So it is reverse. Okay, so when x is between 0 to 1 minus log 2, okay, e to the power of 1 minus x goes between 2 to 3, which means GIF of e to the power of 1 minus x is 2 in that range. Okay, similarly, when it is 1, let's check. Okay, e to the power of 1 minus x equal to 1 you take. Okay, e to the power of 1 minus x is equal to 1. That means 1 minus x equal to 0, or x equal to 1. Okay, so that means between 1 minus log 2 and 1, when, okay, e to the power of 1 minus x is between 1 and 2. Okay, but which means e to the power of 1 minus x will be 1 in this range. Okay, hope you understand how you got it. Okay, here we equated it to 2, and then went 2 and below, basically when it is below that value. Okay, then here next value, basically from 1 minus log 2 to 1, what happens? Okay, this ranges from 1 to 2, which means this GIF value always will get 1, and anything other than that, you will get more than less than 1, which means GIF is 0. So as x is greater than 1, x is greater than 1, okay, you always get this e to the power of 1 minus x between 0 and 1 fractional value. Okay, for fractional GIF it is 0. So you have 3 ranges, 3 you got it. So your integration, basically integration from 0 to e cube of GIF of 1 by x to the power of minus 1 dx is nothing but integration from 0 to 1 minus log 2, okay, plus integration from 1 minus log 2 to 1, plus integration from 1 to e cube of same GIF of 1 minus 1 by x to the power e to the power of x minus 1. Now we know that in this range this is 2, correct? So first one is 2, second one is 1, third one is 0. So this you can ignore. These two you apply limits, basically. Okay, this is nothing but 2x. So 2 times, if I apply limits, 1 minus log 2, because 0, lower limit is 0, so we don't need to do. Okay, plus this is x. So if I apply 1 minus log 2 plus 0, so simplify, what you will get is this is 2, you will get actually 2 minus log 2. Okay, this is nothing but 2 minus log 2 equal to alpha minus log 2, which means alpha is 2, alpha cube is 8. Okay, so this is how you should do. So most of the complicated problems in integration and differentiation are where you see GIF and modulus. Okay, these are all, you need to think more than doing it. These are all easy problems, but you need to think more carefully. Okay, next. Okay, again, square brackets denote the GIF. Then if 24 times integration of 0 to pi by 4 of sine of modulus of 4x minus pi by 2 plus GIF of 2 sine x dx equal to 2 pi plus alpha, then what is alpha? Okay, this involves both GIF as well as modulus. So this is really a good problem. If you solve this one, then you understand how to do integration of GIF and modulus easily. Okay. So let's break this problem into two. Okay, we can clearly see we can apply integration on this part and apply integration on this part separately, right? Second part is easy. Second part is easy, which we have solved just now. We need to find out what are the ranges, and then the GIF value should substitute right in that range. So let's take divide into two parts. I1 is, let's take easy one, 24 times integration from 0 to pi by 4 of GIF of 2 sin x dx. Okay, so from 0 to pi by 4, 2 sin x will move from 0 to 1. Okay, 0 to 1. That means 2 sin x changes to 1 at x equal to pi by 4. It will be x equal to pi by 6. It is 1. Okay, x equal to pi by 6. It is 1. And then uh, so we know that pivotal point, right? Otherwise, it is less than 1. Okay, so I1 I will write it as 24 times 0 to pi by 6. 0 to pi by 6, 2 sin x, GIF of 2 sin x dx plus 24 times integration from pi by 6 to pi by 4 of GIF of 2 sin x dx. Okay, we know that in this range it is less than 1. So less than 1 means this is 0, correct? In this range this is more than 1, but less than, of course, not more than 1. This is around 1. Okay, at pi by 6 it is 1, correct? So you will get 2 sin x more than 1 in this range. So this is 0, this is 1, this is you can ignore. So this one is x. Solution is x, 24 times x, and limits we need to apply. So pi by 4 minus pi by 6. 24 times pi by 4 minus pi by 6, you will get I1 as 2 pi. So this integration is 2 pi. We got it. Now second part. Okay. Modulus is more simple compared to GIF actually. The only thing is just be careful. Okay. When this will become negative, that is what we need to check. Okay, when this becomes negative, I need to make it reverse. That's all, right? Okay, I need to apply just minus sign in front. Okay, 4x minus pi by 2 is equal to 0. Okay, so I want to know when it is pivotal, 0 value. Then I know that at this juncture it is less than 0. At this juncture it is greater than 0, right? So 4x minus pi by 2, pi by 12 is 0, which means x is pi by 48. So I should break this one 0 to pi by 4 into two parts, 0 to pi by 48 and pi by 48 to pi by 4, right? That's it. Okay, so 0 to pi by 48, what will become? It will become, because it is negative, it will become sine of pi by 12 minus 4x. That's it. Okay, so this is into two parts, integration of 0 to pi by 48, and sorry, this is wrong. This is pi by 48 to pi by 4. Okay, pi by 48 to pi by 4. Now, if I apply integration is, I know sine integration is cos. So this is nothing but minus cos actually, right? Sine integration is minus cos of pi by 12 minus 4x, okay, divided by minus 4. So minus minus gets cancelled. So 1 by 4 cos of pi by 12 minus 4x, okay, limit 0 to pi by 48. Similarly, this is actually plus, okay, but since sine integration is minus cos, I took the minus here. Okay, so cos of 4x minus pi by 12 divided by 4 is the integration, and then limits are here. So now carefully put the limits, actually you will get the value. Okay, this is 6 times, because 24 by 4, 6 times 1 minus cos pi by 12 minus 6 times minus cos pi by 12 minus 1, okay, which is equal to 12. Now I is nothing but I1 plus I2, so 2 pi plus 12, which is 2 pi plus alpha. That means alpha is 12. Okay, hope you understand this. Next, if limit of t tends to 0 of integration from 0 to 1 of 3x plus 5 whole to the power of t dx whole to the power of 1 by t equal to alpha by 5e into 8 by 5 to the power of 2 by 3, then what is alpha? Okay. So basically you need to solve this limit and integration, then put it in that form, okay, the form which they have given, and then what is alpha, you map it. Okay, so let's do. First thing is you substitute limit, right? You substitute to t equal to 0 and see what happens. When t is 0, This is 1 dx. 1 dx is x. If I apply limits, it will become 1. 1 to the power of infinity form it is. 1 to the power of infinity means I cannot, it's indeterminate form. I need to find out other ways, right? Okay. Now we have a to the power of 1 by t term. So obviously you should take logarithm to solve this problem, correct? So let's take logarithm on both sides. What we'll get is L is, let's say L is this limit t tends to 0 integration to the power of 1 by t. Then log L is limit t tends to 0, which is as is. 1 by t will come front, 1 by t into log of this integration value. Okay. Now let's see how to solve this one. Okay. So this is limit t tends to 0, 1 by t log of this integration. This integration is simple, x to the power of t dx. Okay. Look at the variable is not t, variable is x. So this is nothing but x to the power of t. X to the power of t integration is x to the power of t plus 1 divided by t plus 1. Because there is a quotient of 3 in front of x, you will also divide that with 3. Okay. Limits from 0 to 1. Now you expand it, you will get limit t tends to 0, 1 by t log of 1 by 3, 8 to the power of t plus 1 by t plus 1 minus 5 to the power of t plus 1 by t plus 1. Okay. Now at this juncture, if you substitute t equal to 0, what happens? 1 by t, so denominator is 0. But what happens to the numerator? Okay, t is 0, so 8 minus 5. Okay, because this is 1, 8 by 1 minus 5 by 1, which is 3. 3 by 3 is 1. So log of 1 is 0. So 0 by 0 again you are getting, right? So we are getting, if you substitute t equal to 0, we'll get 0 by 0. So we need to apply L'Hopital rule. Correct? So differentiate numerator and denominator. Denominator is simple t. So you will get 1 here. So numerator is this log. We need to differentiate this one. Okay. Carefully if you do, we'll get the answer. Okay. So let's call this one f of x. Okay. All we need is f dash x. That's all. Okay. F of t you can call. Okay. So f of t is nothing but log of 8 plus 8 to the power of t plus 1 minus 5 to the power of t plus 1. I took this one, it 1 plus. Okay. Minus denominator, which is log of t plus 1 minus log 3. Okay. Because this is multiplied with 1 by 3. Correct. So minus a log of 3. If I differentiate this, f dash x is, or f dash t is, okay, this will become 8 to the power of t plus 1 log of 8. Okay, 8 to the power of t plus 1 log of 8. Sorry, first thing is this whole thing 1 by, okay, log of x differentiation is 1 by x, right? So this whole thing is goes to denominator first. 8 to the power of t plus 1 minus 5 to the power of t plus 1. Okay, then you differentiate this one. Differentiation of 8 to the power of t plus 1 is 8 to the power of t plus 1 into log 8 minus differentiation of this one 5 to the power of t plus 1 is 5 to the power of t plus 1 into log of 5 minus differentiation of this one 1 by t plus 1. This is 0. Differentiation of this one is 0. So I'm here. Okay. Just simplify. Okay. Now I need to apply limit. Correct? Because denominator is anyway this t, differentiation of t is 1. So denominator is 1. If I apply t equal to 0 now, I don't get a 0 or 1. Okay, 0 basically, I don't get 0. So, or infinity basically, I don't get. So, if I substitute it carefully, what I'll get is 8 log 8 minus 5 log 5 divided by 3 minus 1, which I can write it as log of 8 to the power of 8 by 5 to the power of 5 whole to the power of 1 by 3. Okay, minus log e. This is log e. So, I can take this e inside now. Correct? Minus, so it will come in the denominator here. Okay. So log L is nothing but log of 8 to the power of 8 by 3 divided by E 5 to the power of 5 by 3. Now look at this. I need only 2 by 3. Correct? So keep 2 by 3 and take rest. If I keep 2 by 3, I am left with 6 by 3, which is 8 square. So 8 square is out. If I keep 2 by 3, I am left with 3 by 3, which is 1. So 5 to the power of 1 I am taking out. So 5e here. So now this is the form I am looking at. Okay. Both sides, if I cancel log, L is 64 by 5e into 8 by 5 whole to the power of 2 by 3. You compare, you get alpha is 64. That's the answer. Okay. Next. Let f is a function defined from positive real to real is a twice differentiable function. If for some a which is not equal to 0, integration from 0 to 1 of f of lambda x d lambda is equal to a times f of x. And few values given, f of 1 is 1, f of 16 is 1 by 8. Then what is the value of 16 minus f dash of 1 by 16? Okay. So all we need is find out f of x first. Okay. and then we can substitute the values and then do remaining things, right? So this is the given information. First thing is convert it into, instead of lambda x, you convert it into simple term. Okay, so take lambda x as t, so x d lambda is dt, then limits will change from 0 to 1 to 0 to x. Okay, so now the integration is nothing but integration from 0 to x of f of t dt by x. X is a constant here. Okay, remember, it's not variable, t is the variable. Okay, which is nothing but 1 by x integration from 0 to x of f of t dt, which is equal to a f of x. Okay, this is one important thing. First convert it into a simple integration function. On both sides you have only f. Okay, f of t is here, f of t dt, f of x is there, so which is good actually now. Okay, so now this means integration from 0 to x of f of t dt is nothing but ax f of x. Now if you differentiate, okay, you will get at least one value, right? That is, differentiate on both sides, you get f of x. Okay, if I differentiate here, actually Leibniz formula, Newton-Leibniz formula, I have to substitute f of x minus f of 0. Minus f of 0 is a constant, so it will go off in the differentiation. So f of x. F of x is equal to a f of x, differentiating this basically. Okay, first I am differentiating ax, so a into f of x plus ax into f dash x. Okay, now I'll just convert into f dash x by f of x form, this one. So f dash x by f of x is nothing but 1 by a 1 by 1 minus a by ax. Okay, now again this is, I can integrate. Okay, if I integrate on both sides, basically it is 1 by x form, both sides actually, right? So I'll get here, if I substitute f of x as t, then f dash x dx is dt, so this is 1 by t, so log f of x. Okay, it is log f of x, which is equal to 1 minus a by a into log of x plus constant k. Now use these values to get the k and a value basically, right? So that's what we do. For x equal to 1, if you substitute x equal to 1, f of 1 is 1, which means log of 1 is 0. Okay, and here also it will be 0, so k is 0. Okay, now k value we got, so this is my f of x. Okay, f of x is nothing but, if I take log out actually both sides, this will go as power of x, correct? X power of 1 minus a by a. Okay, and take the log out, f of x equal to x to the power of 1 minus a by a. Now you substitute second value to get a value. Okay, so f of 16, which is 1 by 8, is equal to 1 by 8, I can write it as 2 to the power of minus 3, which is equal to 16 to the power of 1 minus a by a, that I can write it as 2 to the power of 4 minus 4a by a. So you can equate 4 minus 4a by a is equal to minus 3, or a is equal to 4. Okay, so once you know that a is 4, now my f of x is nothing but x to the power of minus 3 by 4. F dash x is minus 3 by 4 into x to the power of minus 7 by 4. Okay, and then 16 minus f dash of 1 by 16 is nothing but, you simplify it, what you will get is, in terms of this one, you will get 16 plus 3 by 4, 2 to the power of 7. Okay, so just find out the value, 16 plus 96, which is 112. That's the answer. Next. Okay, yeah, this is a very interesting problem. It looks very complicated, but you can use Riemann sum identification method to solve it. So it's very simple. Okay, so limit n tends to infinity of n by square root of n to the power of 4 plus 1 minus 2n by n square plus 1 into square root of n to the power of 4 plus 1. Okay, plus n by n to the square root of n power 4 plus 16. So if you see the terms, there are two terms which are repeating basically, correct? There are two terms, a minus b, and they are repeating, okay, in a series, and n is tending to infinity. Okay, this is the n. Only confusion he created is basically this value 1, correct? 1 is here. Okay, so this should be changing next to this is 1 to the power of 4, this is 2 to the power of 4, so this will become r to the power of 4 if I take different from n, correct? And second one is n square plus 1, so this is 2 square, second term, so this will be r square. N to the power of 4 plus 1, it is plus 1, 1 to the power of 4 and 2 to the power of 4, so this is 2 square r square plus r to the power of 4. Okay, so this is r square r to the power of 4. If you write it, you get this very easily. Okay, if this limit is equal to pi by 4, then what is k square? Pi by k, then what is k square? Okay, So first thing is convert this into two separate limits, okay, because there are two series involved here actually. So limit n tends to infinity, n by square root of n to the power of 4 plus 1 plus n by square root of n to the power of 4 plus 16 up to n by n to the power of 4 plus r to the power of 4. Okay. Similarly, second limit also I wrote it here. Okay. Now you write it. You should remember the remain some identification. We need x term basically, correct? So you take this generalization, write it in a summation method. In summation, this is what it is. N tends to infinity. Sigma of r equal to 1 to n, 1 by n of, okay. How I got 1 by n? I'll tell you. You take this one. You take n to the power of 4 common, okay. So it will come out as n square. N by n square is 1 by n, okay. Now here n to the power of 4 is out, so it is 1. So under root, in the denominator I am left with square root of 1 plus r by n whole to the power of r, okay. So this is in the form of integration actually, right? Similarly, minus limit n tends to infinity sigma r equal to 1 to n. Now here, if I take n square common here, n square common here, okay, I am left with 1 by n, okay, 1 by n I am left with, and then here 1 plus r by n whole square, and then here I am taking n to the power of 4 common, so it comes out as n square, okay. So in the numerator I have r by n whole square, okay. So hope you can do it easily, okay. I have taken n square common here, n to the power of 4 common here, so I am getting n to the power of 2 here and n to the power of 2, n to the power of 4. So with, right, so all I am left with is basically 2 times 1 by n is here, n cube, right? I need to account for n cube. 1 n square is here, 1 n is here, n cube, okay. So this is nothing but sigma r equal to 1 to n, where limit n tends to infinity, 2 times r by n whole square divided by 1 plus r by n whole square into square root of 1 plus r by n whole to the power of 4. Now I can simply change this to x, okay. This will become my delta x, and the limits will change to 0 to 1. How to calculate limit? This is very simple. You can remember actually. This will become 0 to 1. But how to calculate limits? In my previous video, I have explained actually. You can just go through that once. Okay. So this is integration of 0 to 1, 1 by square root of 1 plus x to the power of 4 minus, okay, integration from 0 to 1 of dx by 1 plus square root of 1 plus x to the power of 4 minus, again, integration from 0 to 1 of 2x square divided by 1 plus x square into square root of 1 plus x to the power of 4. Okay. So this is nothing but, if I basically combine these two, okay, what I will get is integration from 0 to 1 of 1 minus x square divided by 1 plus x square into square root of 1 plus x to the power of 4 dx, okay, which is, if I take x square common again, x square common, this will become 1 by x square minus 1 divided by, okay, 1 by x, here I am taking x common, okay, here I am taking x square common, so 1x will come, both x square common gets cancelled, okay. So 1 by x plus x into square root of 1 by x square plus x square dx, okay. Now this is what we got. Now if I take 1 plus x by 1 plus x plus 1 by x as t, then this will become 1 minus 1 by x square dx is dt, okay. So this will be negative, that's all, okay. 1 x plus 1 by x as t, so 1 minus 1 by x square dx is dt, which is just negative of this value, okay. So, and x square plus 1 by x square is nothing but t square minus 2, and limits will change, so you substitute the values, 0 to 1 will become infinity to 2. So my integration is nothing but minus integration from infinity to 2 dt by t into square root of t square minus 2, which if I negative, if I make it reverse, limits I can make it reverse, right? So 2 to infinity integration dt by t square into square root of 1 minus 2 by t square. I just took t square common, okay. So now I will take 1 by t as k, so minus dt by t square is dk, limits will change 2 to infinity to half to 0, okay. So half to 0 of minus dk by square root of 1 minus square root of 2k whole square, okay. Basically this is 2k square, okay. So this is nothing but again negative, and the limits I am changing. So 0 to half of dk by square root of 1 minus root 2k whole square. This is a simple sine inverse, right? This is a simple sine inverse. So 1 by square root of 2, because there is a coefficient of k, I wrote it in the denominator, sine inverse of root 2k, limits from 0 to half. If I substitute the values, I get pi by 4 square root of 2. This is in the form of pi by k, which means k is 4 root 2 and k square is 32. That's the answer. Okay, next. Again, step function again, GIF function again. Okay, so square brackets t denotes the largest integer less than t. If integration from 0 to 3 of GIF of x square plus GIF of x square by 2 dx equal to a plus b square root 2 minus root 3 minus root 5 plus c square root of 6 minus square root of 7. Okay, and then what is a plus b plus c? Like basically you need to solve this one. Okay, and we have solved it before. We need to find out in this range what are the integer values we are crossing. Okay, and then decide, right? That is very simple. I can actually break this into two separate integrations and do, but we don't require. Okay, okay, only thing is you call this as f of x. Okay, now my integrations are from 0 to 1. Okay, 0 to 1, always both of them, both these, okay, this will be less than 1, this will be less than 1, so it will become 0. That's why I took 0 to 1. F of x dx plus integration from 1 to square root of 2, because 1 is there. Okay, square root of 2 I took because this will become 2. This will become 2 by 2, which is 1 again. Okay, so still it is 0. Second part is still 0. Okay, but whereas the first part, that is GIF of x square, will be 1. Okay, plus square root of 2 to root 3, because this is another next integer. This is where I get, okay, root 3 to root 4, root 4 to root 5, up to root 9, because that is where I get 3 basically. Correct? Square root of 9 is 3. So this is how I should write. Now very simple this is. Here both are zeros. GIF of x square plus GIF of x square by 2, both are zeros. In the second limits, GIF of x square is 1, GIF of x square by 2 is 0 still. So 1 plus 0, 2 plus 1, 3 plus 1, okay, 4 plus 2, 5 plus 2, and so on. You write up to all this one. Carefully you check, you substitute the value and see what you are getting. Okay, then you will know. Suppose if you take this one, this is, I need to substitute 3. So 3 square is 9. So I will always guess GIF of something less than 9 more than 8 is always 8. Okay, now here 9 by 2, which is 4.5. So I always get 4. So this is how we should do. Okay, so now this is simple, very simple application. I mean, applying the limits basically. Apply the limits carefully for each one of them. Okay, you will get in this form: 31 minus 6 root 2 minus square root of 3 minus square root of 5 minus 2 root 6 minus square root of 7. Okay, which means a plus b plus c. If I take a is 31, b is minus 6, c is minus 2. A plus b plus c modulus is 23. Okay, actually there is no modulus, but still it is 23 anyway. Okay, that's the answer. Next, let rk is equal to integration from 0 to 1 of 1 minus x to the power of 7 whole to the power of k dx divided by integration from 0 to 1 of 1 minus x to the power of 7 whole to the power of k plus 1 dx. K belongs to natural numbers n. What is the value of sigma of k equal to 1 to 10 of 1 by 7 times rk minus 1? Okay, first thing is you need to find this rk, that is integration of these two. And it's these problems actually, if you see, the integration is exactly same integration you are doing, only difference is some index values are different. Correct? So such problems you need to find out the recursive way actually. So you take which one has highest power, that is here, denominator, correct, is the bigger one, integration to the power of k plus 1 you have, right? Take this one and then express in terms of the other one. Okay, this is what we should do. Okay, so this is the method to solve some of the integration problems using this one. Okay, so let's call the denominator as I of k plus 1, which is equal to integration from 0 to 1 of 1 minus x to the power of 7 whole to the power of k plus 1 dx. Okay, integrate by product rule. You take the f of x as 1 minus x power 7 whole to the power of, sorry, not k plus 1, and g of x equal to 1. Okay, so product rule I am applying. First is f of x, so 1 minus x to the power of 7 into whole to the power of to the power of k plus 1, integration of 1 which is x, okay, the limits I am applying 0 to 1 minus integration of 0 to 1 of differentiation of f of x which is k plus 1 into 1 minus x to the power of 7 into 7 to the power of k into differentiation of minus x to the power of 7 which is minus 7 x to the power of 6, okay, into integration of 1 which is x, okay. Carefully you do it, okay. Now if I apply limits to this one, I'll get 0 anyway, because if I substitute 1 here, this is 1 minus 1 which is 0. If I substitute 0, 0 is here into product into 0 which is 0 anyway, so this is 0, okay. So second part I'm taking minus this 7 into k plus 1 outside, so minus 7 into k plus 1 because already minus is here. Integration from 0 to 1 of 1 minus x to the power of 7 to the power of k into minus x to the power of 7 dx, okay. Why I kept it minus x to the power of 7? I can write this as 1 minus, I add 1 here, subtract 1, okay, added 1, subtracted 1, correct. Now this 1 minus x to the power of 7 whole to the power of k, I will take inside, multiply with this, it will become 1 minus x to the power of 7 whole to the power of k plus 1, okay. So you can see here, this is nothing but 7 times k plus 1 of, okay, 7 times k plus 1 of, okay, minus sign I'm taking inside, so whatever comes reverse basically, okay. So this is negative part will become first, okay. So integration from 0 to 1 of 1 minus x to the power of 7 whole to the power of k. I am multiplying this with minus 1, so which is minus into minus which is plus, okay. Now I am multiplying 1 minus x power 7 with this, okay, and I have minus sign, so minus, okay, integration from 0 to 1 of, okay, 1 minus x to the power of 7 whole to the power of k plus 1 dx. Now we know that this is exactly I k plus 1 again. This is I k, this is I k, this is I k plus 1, correct. So this is nothing but 7 times k plus 1 of I k minus I k plus 1 which is equal to I k plus 1, correct. Now we got a recursive relation. Now this is very simple to solve this one. How we can do this? I k by I k plus 1 is nothing but, this is what I need, right? This is I k, this is I k plus 1. I k by I k plus 1 is nothing but, if I put here, this will become, right? From this one I can derive very easily, right? You take all ik terms one side and ik plus 1 terms one side. This is what you get, 7k plus 8 divided by 7k plus 1, and this is what I am looking, okay, right? So this is nothing but 1 plus 1 by 7k plus 7 which is equal to rk. This is rk, this is rk, okay. Now it is just a matter of simplification. What is rk basically, okay? So if I take 1 by 7 times rk minus 1, then I'll get k plus 1, okay. So this is nothing but sigma k equal to 1 to 10 of k plus 1, okay, because this is nothing but k plus 1, okay. You just solve it from here, okay. So that is sum of 1 to 11, sum of sorry 2 to 11, okay, which is sum of 12, sum of 1 to 12, basically 1 to 11 minus 1, okay, that's what I get it. So that is 65 is the answer, okay. Sum of 11, 1 to 11 basically minus 1, 1 is not there, it's starting from 2 actually, correct. So minus 1, that is 65 is the answer. Next, this is one of the technique actually, very important technique. Express one integration in terms of the other. Basically most of them are index based or power or something will be common, okay. This is how we should do. Next, f of t equal to integration from 0 to pi of 2x dx by 1 minus cos square t sin square x, okay, where is t is between 0 and pi. Then the value of integration from 0 to pi by 2 of pi square dt by f of t, okay. So first thing is you need to find out this f of t, then you need to solve this integration, correct. How to do that? This is cos square t is a constant here, okay, don't get confused. Cos square t is a constant. So all these problems basically where you have numerator as x and then sine square, first you need to get rid of this x. How do you do that? The powerful definite integral rule is there, right? Which you substitute pi plus 0, x equal to pi plus 0 minus x, that is pi minus x if you substitute, okay. Substitute, what happens is f of t will become 0 to pi of pi minus x, sorry 2 times also there, I just missed here, 2 times pi of pi minus x into dx divided by 1 minus cos square t. Sin square x will remain same because sin pi minus x is sin x only, okay. Now this one and this one if you combine, x term will go off basically, x term will go off. So 2ft equal to integration from 0 to pi of 2 pi dx divided by 1 minus cos square t sin square x, or 2 both sides if I cancel. This is nothing but f of t is nothing but integration from 0 to pi of pi dx divided by 1 minus cos square t sin square x. Okay, now next. Whenever you see sin square x in the denominator, sin or cos, you have to convert into secant and tan, right? So that's what I'm doing here. If I divide numerator and denominator with cos square x, what I will get is integration from 0 to pi of pi secant square x dx divided by secant square x minus cos square t tan square x, which is equal to 0 to pi. I am making it into half, 0 to pi by 2, 2 times basically. Okay, 2 times. Normally, this rule is applicable whenever you substitute such things. Okay, this is follow up actually. Always you should limits you will change, because this is a even function. Difficult to apply limits later. Okay, so convert into this, it is easy. Okay, 2 times pi 0 to pi by 2 of secant square x dx divided by secant square x minus cos square t tan square x. Okay, now you take tan x as t or k basically. Okay, t is already there, that's why tan x is k, secant square x dx is dk. Limits will change 0 to pi to 0 to infinity. Okay, so 2 pi 0 to infinity dk by 1 plus k square minus cos square t k square, which is nothing but 1 minus cos square t sin square t. So denominator will become 1 plus sin square t k square. Now this is exactly in the form of tan inverse, correct? This is a coefficient. This is a coefficient of k. Okay, so that is nothing but 2 pi into 1 by sin t, because this is coefficient of k. Tan inverse of sin t into k divided by 1, limits 0 to infinity. That's it. Okay, now you substitute infinity. If you substitute, you get pi by 2. 0 you substitute, you'll get 0. So this is 2 pi by sin t into pi by 2 minus 0. This is my f of t is nothing but pi square by sin t. F of t is pi square by sin t. So this whole thing will become sin t. Okay, so my integration is very simple now. My integration finally I should find it. Integration from 0 to pi by 2 of sin t dt, which is minus cos t. Apply the limit 0 to pi by 2. I get the value 1. That's the answer. Next. Okay. If the shortest distance between the lines x plus 2 by 2 equal to y plus 3 by 3 equal to z minus 4, z minus 5 by 4, and x minus 3 by 1 equal to y minus 2 by minus 3 equal to z plus 4 divided by 2 is 38 by 3 square root of 5k, and integration from 0 to k of gif of x square dx is alpha minus square root of alpha. Then what is 6 alpha cube? Okay, another GIF problem here. This we have solved before. This is simple. Only thing is to find out this 3D geometry problem. That's all. That is the only thing. From where you get k, correct? So you should remember your 3D geometry solution for this. This is a very basic question from 3D geometry. Distance between shortest distance between two lines. Correct. So this is my L1. Correct. This is my line 1. If I write in point and direction form, this is what it is. If I call this a bar, okay, a bar is point, minus 2, how I got minus 2, minus 3, 5, minus 2, minus 3, 5. This is nothing but minus 2i plus minus 3j plus 5 k. Okay, now my direction vector is, okay, a bar, small a bar, which is 2, 3, 4, which is below. Okay, now similarly I should take from L2. Okay, my L2 b bar, capital B bar, which is point is 3, 2, minus 4, and direction is 1, minus 3, 2. Okay, now the distance formula is here. Okay, modulus of b bar minus a bar, dot product with a bar cross b bar divided by modulus of a bar cross b bar. Okay, so first thing I should find out is a bar cross b bar. Correct, you will find from the matrix modulation, right? ijk, and a is 2, 3, 4, b is 1, minus 3, 2. I write it here. So I'll get ijk values basically 18i plus 0j minus 9k. So that is nothing but 18 comma 0 comma minus 9. My modulus of this one is square root of 18 square plus 9 square, which is 9 square root of 5. Okay, now I have all the info, right? And b minus a vector is nothing but subtract b minus a. Okay, so 3 minus of minus 2, 5. Okay, then 2 minus of minus 3, which is again 5. Then minus 4 minus 5, which is minus 9. This is my b minus a. So I have to do dot product this one with a cross b. Dot product if I do 18 times 5 plus 0 times 5 plus 9 times 9. Correct. So my dot product is 171. Okay. So this is a simple 3D geometry problem actually. Once you remember, this is very easy, very basic problem. Distance is nothing but 171 divided by 9 root 5. 171 divided by 9 root 5, which is, if I simplify, 38 divided by 3 root 5 k. Okay, so k is nothing but 3 by 2. Now I got my k. Now all I need is integration. Integration from 0 to 3 by 2, gif of x square dx. So I know this will change from 0 to 1, 1 to root 2, root 2 to 3 by 2. Correct? 0 to 1, it's always gif is 0 between 0 to 1. So I did not write it here. So integration from 1 to square root of 2 gif of x square plus dx plus integration from root 2 to 3 by 2 gif of x square dx. Okay. So in the first case, this is 1. This case, it is 2. Correct. Apply the limits carefully. Root 2 minus 1 plus 3 minus 2 root 2. Simplify it, I'll get 2 minus square root of 2, which is in the form of alpha minus square root of alpha. So alpha is 2. So 6 alpha cube is 48. Okay. Hope you understand how to do this. These are the problems I cover in this video, which are all different actually, very different from the previous problems I have solved. So keep doing more of such problems and keep doing more variety of problems to cover all the techniques and information regarding definite integrals. Thank you.